So let's begin to understand angle of repose. The angle of repose exactly क्या है? So if we place something on a horizontal surface, तो अगर अपने किसी चीज को horizontal surface पे रखते हैं, तो the weight of this block is in the downward direction, and then it will be getting a normal reaction force from this surface, and eventually in equilibrium, the normal reaction force will be equal to mg, and the block is not moving unless an external force is applied, which is greater than the friction which this surface will offer. Now, if we increase the inclination of this surface, then at a certain angle of inclination, the component of weight which will be acting down the incline will make the block slide due to its own weight. तो जब ये एंगल अपने रीच कर लेते हैं, where the block will start to slide under the influence of its own weight, then we call that angle as angle of repose. So if we draw the FBD of this block, we can say that the weight mg is in the downward direction. Now if we break the component of mg perpendicular to the incline and down the incline, then we can say that this angle is theta. So the component of weight here will be mg cos theta, and down the incline will be mg sin theta. Now this surface will offer a normal reaction force in this direction. And if we think in terms of frictional force, then the block will start sliding only when the force down the incline exceeds the frictional force which is in this direction. So if we calculate the normal reaction force, then we can say that in this direction, or which we regard as y-axis, so if we regard this as y-axis and this one as x-axis, so we can say that normal reaction force that is in the upward direction is balanced by mg cos theta in the downward direction. And if we calculate the value of frictional force, so we will have two values. The maximum value of static friction, that is equal to mu s multiplied by normal reaction force. So we get mu s mg cos theta. And if we calculate the kinetic friction value, then the kinetic friction value is going to be mu k times normal reaction force, that is mu k mg cos theta. Now the block will start sliding down due to its own weight only if this value mg sin theta becomes equal to the coefficient of static friction value, that is Fs maximum. Why we are taking this value and not this value? Because the block is initially at rest. Now in order to bring the block in motion starting from rest, we need to defeat or overcome the coefficient of static friction value. That is why we are taking the value associated with the static friction. And now if we equate them up, we get mg sin theta equals mu s mg cos theta, and on solving we obtain tan theta equals mu s, or theta equals tan inverse mu s. Now let us do a quick experiment to calculate the coefficient of friction between a surface and the block. So let's begin by calculating the angle of repose. So what is angle of repose? We have already summarized it up. The angle at which the block starts sliding down due to its own weight. So we will find that angle, and then we will use that angle to calculate the coefficient of friction between this surface and the block. So let's get started. So what we have an inclined plane arrangement, और यहाँ पे अपने angle measure कर रहे हैं using a protector which is placed about this axis. So we will fix the block over here, and we will find out at what angle the block starts sliding due to its own weight. So as we increase this angle of incidence, a component of the weight of the block is acting down the incline. If we increase this angle further, we can see that at this angle, the block is sliding down due to its own weight. Let us check again. So this is the angle at which the block is sliding down due to its own weight. So we will fix this angle. So at this angle, we mark the angle of repose for this arrangement. So using this angle of repose, we will calculate the coefficient of friction. So experimentally, we have obtained the value or the angle at which the block starts sliding down to be 20 degrees. Now, if we use this 20 degree, then we can use it to find mu s, which is equal to 10-20 degree. And on solving, we obtain 0.3639, which we can roughly say the value is equal to 0.36. So the coefficient of friction between the wooden block and the glass surface is 0.36.